minus 1, minus 4, negative. And then you list the transformations. The backwards is I list the transformations, then you write the functions. Is that what you meant?
Yeah.
The backwards here where you write the function from it?
Yes.
Okay. All right, let me snip in this right here. It's really the horizontal ones that are the weirder, tougher ones.
Yeah.
So let's say here, okay, let's say it's left 4, horizontal shrink of 2. So whenever you see something horizontal, whether it's shrink or stretch, this number gets converted to its reciprocal.
Mm-hmm.
So this really means 1/2. Okay. And then we'll go reflected over the y-axis, and we'll go up 7. And we'll say that the parent function here, we'll say that f of x was x cubed.
Okay.
So do you want to give that a try first? Or do you want me to go through this one?
Could you go through it, please?
Absolutely. So here's what left 4 looks like. It becomes x plus 4 cubed. The shrink of 2, so the shrink, the horizontal shrink of 2 is 1/2 x plus 4. But see how I added some extra parentheses here? Because if you go back to your picture here, this b is on the outside of these parentheses from the left or the right shift. Okay. So then the horizontal reflection, we put a negative inside parentheses again. Okay. And then the last one is up 7. So we take exactly what we had here, cubed plus 7.
Okay.
And that's it.
Okay.
So let's try another one here. Let's say you're starting with f of x equals the square root of x. So the first thing we'll do is we'll go right 3. We'll do a horizontal shrink by 4, and that turns into a different number. And then we'll go, this time we'll do a vertical reflection. And then we'll go down 8.
Okay.
So see if you can do that one at a time. I guess we can actually do it right over here, each of these. This is 1/4 here. We can show each of them.
Okay.
Okay, so let me go through each of these. So it's square root x minus 3. Okay, and you can even start putting this in parentheses if that helps. The horizontal shrink by 4. It's still under the square root, but it's outside of the parentheses. The vertical reflection is a negative on the outside. And then down 8 is adding to the end. So outside of it's a +8. Is that your final answer for that one?
Yes.
Great. Let's do another one. Let's say it's x squared. Let's go left 3. Horizontal stretch by 5. So the stretch, if we go back and look at our wording here, it says it's a stretch if it's less than 1. I'm a little, so this is, I'm sorry, this is the one we want to flip. The other one we didn't want to. I got these mixed up here. So that's 4. And then this one is 2. It's just a minor thing, but you just be careful that you really memorize that in there.
Okay.
Okay, so let's go back to this one. And let's do a horizontal reflection. Let's do a vertical stretch by 7. And then let's go up 12. So give that a try.
Okay.
I'm sorry. The left 3 is x plus 3 squared. The horizontal stretch by 5, it goes inside the parentheses before you square. The horizontal reflection is the negative inside parentheses. And then the vertical stretch by 5, that one is as is. So you just put that number out there on the outside.
Okay.
And then the up 12 is that last little piece, negative 1/5 x plus 3 plus 12. Now, like in full disclosure, some of these don't even make sense because when you square them, they end up going outside, the negatives go away, but like this is the this is the like recipe. It's just a little bit odd for some of these. Like it only seems to work for some of these where you can get this behavior.
Mm-hmm.
Like in a parabola, a horizontal stretch and a vertical stretch can be done in similar ways.
Mm-hmm.
So it's yeah, anyway. Okay. Do you want any more of those, or do you want us to move on to something else?
Can we move on, please?
Okay. So let me give you some functions here. Let's say f of x equals the square root of 9 minus x. G of x is x squared plus 1. And then we'll make a table. Here's x, h of x, and we'll go -3, -2, -2, 2, -1, 0, 0, 1, and 1, 4. Okay, so what is f plus h of 0? Okay, so this is like one of those we'll do together here. So this notation, hopefully you've been seeing this in class. It's f of 0 plus h of 0.
Okay.
So the letter tells you like where to go. Like f's a function, g is a function, h is a table. So for f of 0, this is like the square root of 9 minus 0.
Okay.
H of 0 you get from the table. What is h of 0?
0.
Looks like it's 1.
Oh, yeah, 1.
Okay, so this is 1. Square root of 9 minus 0 is 3. 3 plus 1 is 4.
Okay.
All right. Okay, so let me grab these again. I'm going to just copy these down and we'll do another one.
Okay.
So this time I want you to find f minus g of 5.
Um, 28.
So f of 5 minus g of 5. So f of 5 is the square root of 9 minus 5, which is the square root of 4. And that's 2. G of 5 is
Oh,
5,
minus.
5
Okay.
squared plus 1. And you're subtracting all that. So it's minus 26. So negative 24.
Oh, okay. I just forgot to. I thought I was adding. Oops.
Okay, let's do one more of these, and then I'll go grab the ones from your book because they're a little bit better. This is pretty hard to make on the fly. That actually works. Let's do some composition now. So composition would be f of f. Now let's not make that complicated yet. Let's go g of f of 0. And sometimes this is written this way. It's g bubble f of 0. And that bubble, it's not multiply. I am saying the word bubble. Hopefully it looks like a bubble, like that. So which do you do first? The outside or the inside?
The inside.
The inside. So you got to figure out what is f of 0.
3.
3. So then you got to now say, oh, well, that's g of 3. What is that?
10.
It is 10, okay? So now let's do another composition here where it's of itself. So let's do this. Let's say it's g of x. Let's do that one first. What is g of x? It's x squared plus 1, right?
Mm-hmm.
You're used to seeing a number there, but it could be just a function. So g of that means to take x squared plus 1 and put it back in wherever you see an x.
Okay.
So that's x squared plus 1 squared plus 1.
Okay.
Have you seen that? Is that okay?
I'm a little confused by that.
Okay, so let's try something different here. Let's say f of x equals 3x plus 1 and g of x equals x squared minus 2. F of g of x. Which do you start with, the outside or the inside?
Inside.
The inside. The inside is x squared minus 2. So this is like saying f of x squared minus 2. And what this means is wherever you see an x, you're going to replace it with x squared minus 2. So this equals 3 times x squared minus 2 plus 1. So you take this and you put it in for x.
Okay, that makes more sense.
Okay, but you got to be able to do it both directions. Let's go the other one. Let's go g of f of x. This says start with f of x, which is 3x plus 1, and put that in for x. So 3x plus 1 squared minus 2. Is that clear or not?
Yes.
Okay. All right, that's good. Now, let me rewrite these one more time. F of x is 3x plus 1, and g of x was x squared minus 2. Okay, so now let's try this f of x. So what that means is you take this 3x plus 1 and you put it back in for x. Because f of x is 3x plus 1. So you take 3x plus 1 and wherever you see an x, you put it back in. So it's 3 times 3x plus 1 plus 1. See, this was x.
Okay.
You follow that? Like
yeah.
Wherever x is, you put the same thing back inside.
Okay.
So what would g of x look like? We're looking at this one over here, g of x. It's like saying g of x squared minus 2. It means wherever you see an x, put in the x squared minus 2 for it. So x squared minus 2 goes in for x minus 2. So this is your x again, or it was your x.
Okay.
I'm still not sure it's completely clear, but we're going to do a couple from the review that you sent me before.
Okay.
Sorry, I got a notification on something that doesn't make any sense. Okay, I'll deal with that later. Let's get to it here. Here we go. Yeah, so this is a little nicer. Okay, so this is from your review. And there's four things, right? There's G, H, I, and J. And the first one that they give you here, that's a composition, is this H of J of 0. H of J of 0. So first thing you've got to figure out is what is J of 0. And that comes from the table.
0.
0. So this equals 0. So it's of J of 0. What is J of 0? It's 0. So which do you use for H?
The x squared plus 6x plus 9.
That's right. 0 squared plus 6 times 0 plus 9, which equals 9.
9.
So let me copy this one down. Let's try and get you to do one more. I think if we just do a couple more of these, I think you'll get a full understanding of it. All right, so let's do I of G of 4.
Six.
What did you get for G of 4?
G of 4.
Did you get
I
2?
got 2. Yeah.
Good. So this becomes I of 2 because G of 4 is 2. The absolute value of 2 minus 7.
Oh, okay.
If you use something else, again, like make sure you're paying attention to what's going on there. So that's absolute value -5, which is 5.
Okay.
Let's do another one. Is that okay?
Yeah.
These don't take that long, but let's have you do enough until you really have this down. Okay. Let's do I of J of 2.
I have a question. So when it's something like J, would you look at the x value because that's 2, and then the answer would be 12? Okay.
Yes, that's the x value. That's exactly right. That's exactly how you should think about it.
Okay. Um, 5.
Yes. Very good. Let's do another one here. Let's do G of H of, sorry, just gonna make sure these values work, of -3.
I'm not sure I did this one right.
Okay, what did you get for h of -3? We'll start with that. What's the number you got for that one?
-18. I don't think that's right.
Okay, so it's -3 squared in parentheses plus 6 times -3. I always like to substitute in parentheses plus 9. So that's 9 minus 18 plus 9.
Okay.
What does that equal? Nine minus 18 plus 9. I'm asking
0.
0. Very good. So now you're going to do, this is really g of 0.
Oh, okay. So,
okay. So see if you can do that.
the square root of 12.
It's the square root of 12. Now that does reduce, but it's not super important that we do that. Okay, let's try another one here. Let's do I of let's go 4. So which one do you start with?
The inside one, I have 4.
I have 4. So give me that value first, please.
Three.
3. So now this is I of 3.
Four.
4. Okay, good. So that becomes I. Let me go down here. I of 4. What is that? What does that one then become?
3.
3. Good. Great. Okay. Do you want to do any more of these?
I think I'm good.
Okay. I think so too. I think that's clear. So the next one, if you're okay with it, I'd like to go to that stuff you sent today to kind of help with this. Is that all right?
Yes.
Okay. So I'm going to snip in the graph and then the actual like analysis next to it.
Okay.
There's the graph. And then here is the things that it's asking for. So it's asking for. Okay. Before we do anything on the left here, could you give me the name of, like this has a well-known name. Do you know that name of this?
A parabola.
Parabola or quadratic, right? Okay. Now, the sign and degree, I think you know, it's basically asking for the exponent power. What is the power of this? X to what power for a quadratic?
X squared.
Yeah, so that's this part. So I'm going to put a slash here 2. Okay. Now, is this opening up or down?
Up.
Okay. So when A is positive, it opens up. When A is negative, it opens down. So that's the sign. It's positive.
Okay.
Okay. Zeros are where it crosses the X axis.
0 and 2.
0 and 2. So, and sometimes they want ordered pairs, 0, 0, 2, 0. or they want you to just write x equals 0, x equals 2. How about the y-intercept? Where does it cross? Yeah. Okay. Now the end behavior, you write something like this, right? As x goes to infinity, y or f of x goes to. As x goes to negative infinity, y goes to.
X goes to infinity, y goes to negative infinity.
So that like that's saying that this doesn't go up, it goes down.
It stays the same.
Yeah, it goes to positive infinity.
Okay. And then is it the same? So like as x goes to negative infinity, y goes to negative infinity?
That would be down here if that were true.
Oh, okay. So that one's positive too.
Yes.
Okay.
All right, let's go to the next one. Oh, okay. So I'll do the same thing and I'll snip it in. Did you get some extra time for this exam, or was it always on Friday?
Yeah, it's always on Friday.
On Friday, okay. All right. Well, you should be really well prepared after this.
Yeah, I think so.
Hopefully, keep your grades up and keep mom and dad happy and all that stuff. So, this one's a little bit different. Like this one has it goes down and it comes up, it goes down. So the correct way to figure out the degree. Okay. Oh, you know what? Yeah, the correct way to figure out the degree is to look for the number of turning points. So how many turning points are? So like that's a turning point, that's a turning point, and that's a turning point. It's where it switches direction, like down to up, up to down. So the degree, and here's the formula, it's really complicated. It's the number of turning points plus 1. So you count the number of turning points, which there are 3, and then you add 1 to it. So the degree is 4. Yeah. All right, so the sign of this, there's really 4 graphs that you have to know. So if the degree is even, there's only 2 possible graphs that you could see. Is it starts high and ends high, starts low and ends low. Okay, so these are of the form a x to the n, where n is even. So it starts high and ends high if a is greater than 0, if a is positive. If a is less than 0 or negative, then you get this behavior over here. Your graph over here on the right resembles this one on the left here. So that means the leading coefficient is positive. The sign is positive. Okay, so the zeros are where it crosses the x-axis. Where does this cross the x-axis?
At 2.
What about here?
0 and
there.
2. Okay, so 2 or negative 2, 0 and 2.
So I think this one is 1. I know it's hard to, it's not written real well, but yeah, 0, 2, and 1. Okay. What about the y-intercept?
0, 0.
0, 0. Okay, so again, the end behavior is as x goes to infinity, meaning like really this means to the right. When you go to the right, what happens to the y value? As I get all the way to the right, what happens?
Positive.
So it goes to positive infinity. So as x goes to negative infinity, y goes to
positive infinity.
Yeah, and I hear a little bit of uncertainty in your voice. You're looking at the arrows. This is positive infinity, and this goes to positive infinity also.
Okay.
Let's just briefly do. Did you get this copy down?
Yes.
Okay. This is really important because I don't think that this is completely clear. Let's say I give you a graph that looks like this. Okay. And we want to do the end behavior. So as x goes to infinity, that's over here on the right. Where is this going to? How far up is this going?
Positive infinity.
So y goes to positive infinity. But as x goes to negative infinity, that's going the other way. How far down is this going?
Negative infinity.
Yeah, what's its definition? It's negative infinity. Okay. Now let's look at another one. Okay. So as x goes to infinity, that's over here on the right. How far down is that going?
Negative infinity.
Y goes to negative infinity, yeah. As x goes to negative infinity, as you go the other way, how far down is this going?
Negative infinity.
Negative infinity. I think you understood this. On a test or exam, sometimes they switch these. They put the f of x first. It's very confusing. So try to put it in the order that you understand. Meaning like usually you trace x first, not y. So yeah, reordered if you need to.
Okay.
Okay. Now what we did kind of skip some stuff here that's kind of important. So let's go back a little bit and do let's try to write the f of x for this first one so you understand how to do it.
Okay.
The best way to do these is always in factored form. And your factors are x minus the zero crossing, like wherever it crossed the zero. So like this one has zeros at 0 and actually that's 4, 2, 4. Okay, so this has the form x minus 0 times x minus 4. Do you see that? But there's really an a here. Did you talk about that in class?
Yeah.
So really it's f of x equals a x minus 0, x minus 4. To find a, we need an x and a y value. So we have that right here. This is 2, negative 4. So we can use that to figure out a. So we're basically saying when f of x is negative 4, x is 2, 2 minus 0, 2 minus 4, negative 4 equals a times 2 times negative 2. Negative 4 equals 2 times negative 2 is negative 4. So this is negative 4a, divide both sides by negative 4, and a equals 1.
Okay.
The next one is slightly more complicated, so we'll look at that together as well. So let me go grab it. So you always try to write it as x, x minus whatever the zeros are. So there's a 0 at minus 2, there's a 0 at 0, and a 0 at 1. So it's x minus a minus 2, which is plus 2. Okay, x minus 0, x minus 1. And then there's always this a in front. So this one is a little more, we're not quite done though. So if it crosses, it has a multiplicity of 1. See how it crosses there?
Yeah.
And at 0, it also crosses. So it has a multiplicity of 1. But at 1, does it cross? No, it touches.
Yeah.
Touches is a square. Is that okay?
Kind of.
Okay, so if it touches, you got to put a 2. If it crosses, it's a 1. It's as simple as that.
Okay.
Like, so the rest is you know, you're kind of done here. This one may or may not have an A, but we'll just do this. It's x plus 2, x minus 1 squared.
Okay.
Okay, so let's look at another one here. I think this one will be clearer. Okay, so let's write the polynomial, or f of x. It's x minus the 0. So give me the 1, 2, 3, 4 zeros. So the first one is at -2. So that becomes x plus 2 because it's x minus a minus 2. What's the next one?
-1.
So it's x minus a minus 1, which becomes x plus 1. Then what do you have here at 0?
0.
So you could write x minus 0. And then over here at 2, x minus 2. So the rule is if it crosses, the multiplicity is 1, or the exponent. If it touches, the multiplicity is 2. That means the exponent is 2. What happens here at -2? Does it cross or touch?
Cross.
You seem uncertain. So it's like imagine this is a river. Did you go over the river? Did you cross the river, or did you come up to it and go away? You crossed it.
Yeah.
Okay, so that's 1. If you don't like that word, I mean, just find a synonym for the word cross. It's like widely used in this class in this context. So like that's the only one I can think of right now. But it goes over the x-axis here at -1, so that's also a power of 1. At 0, it also crosses, does not touch. At 2, it also crosses.
Okay.
Let's look at one more here. Really quick here. All right. So what is going on here and here? What are these called? These are the zeros. Yeah. So you have a 0 at -1. So it's x plus 1 because it's x minus a minus 1. And then you have one at 2, x minus 2. Now at -1, does it cross or touch?
Cross.
Okay, now maybe I understand. It touches here, doesn't it? Touches doesn't mean, maybe that's, so this is a touch, and this is a touch.
Okay.
We need another, maybe that's the problem. It's like passes over. If it passes over, it's power of 1. If it bounces back, if it maybe bounces is a better word. Bounces is a power of 2. Okay. Bounces is a power of 2. And if it goes over, it's a power of 1. Really quickly, I got to do this last one here because it's kind of an exception. Got 1 minute, maybe 2, to do this. So there's 2 zeros here x plus 1, that's for the negative one, x plus 2. This one goes over, so that's a power of 1. This one also goes over, but since it has this bend, it usually is a power of 3.
Okay.
And that's the last little wrinkle there. All right, well, thanks so much for scheduling. I'll send you the notes right away here in the next few minutes. And I think you're going to do great on your exam. If you have time, spend a little more time reviewing, but I think you got it.
Okay, thank you for helping
You're
me.
welcome. Of course. See you next time.
Bye.
Bye.